A pharmaceutical company is researching a new anti-anxiety drug. Marketing the drug is costly, so they only make a profit if the drug's effective for over 80% of their patients. A sample of 60 participants were placed on the drug, and they look at how many responded favorably. So the first question is, give the null an alternative. We're looking at a single sample here, and just yes or no, was the drug effective or not? So we're dealing with a single proportion, and we really want to know, is it effective for over 80%? Okay, so our research hypothesis is the proportion over 80%. Our baseline to go with that for our null then is the proportion 80%. We want to describe in words what a type 1 error would mean. So a type 1 error, very generically, is that you reject the null, but you shouldn't have because the null is true. What would that mean in words here then? If I reject the null, I'm going to cross off the null and I'm going to say I have evidence of the alternative. So that would mean that I do find evidence that we have effectiveness for over 80%. So that's HA, but the null was true. So when really it's only effective for 80%. So that would be in words what a type 1 error would be. Type 2 error then would be the opposite scenario. And a type 2 error, what we are thinking of generically is we don't reject the null or we fail to reject the null, but the null was false. So what would happen if I don't reject the null? If I don't reject the null, I'm not going to find evidence of HA. So I would determine that there's no evidence the drug's effective for over 80%, but really the null was false and it was effective for over 80%. So those would be the two scenarios that could give us like the wrong conclusion here. So the type 1 error probability, if you look at the previous page of notes, is whatever significance level is set. So if the significance level is set at alpha of 0.05, we know then this means that we have a 5% type 1 error rate. The previous page also says that the type 1 error rate and the type 2 error rate go opposite directions. So a small type 1 error rate will produce a higher type 2 error rate and vice versa. So suppose that the type 1 error rate is 0.05 or 5% because we have that significance level. But the researchers find then that produces too high of a type 2 error rate, which is 0.4. So 40% chance of type 2 error. We want to look at two ways they could reduce the type 2 error rate. So one is to use that trade-off between type 1 error and type 2 error. If type 2 error is too big, you can increase type 1 error, so increase alpha, maybe use 0.1 instead of 0.05. That will make the type 2 error drop. So type 1 error went up, type 2 error went down. That's maybe not ideal because all I've done is I've decreased the type 2 error rate by making there be a higher chance of a type 1 error. A better approach, if possible, is always to take a larger sample. We can keep this 0.05 fixed and take a larger sample. That will then decrease the type 2 error rate. And then lastly, we have this quick concept of power. Power is the opposite of type 2 error, so it's a good thing to have a higher power. So if I take 1 minus my type 2 error rate, I get a power of 0.6. So if we were able to reduce the type 2 error rate, maybe to like 0.2 or something, our power would go up then to like 0.8.